Hello, myself Vinod Panara, and in this lecture we discuss about some numerical of friction. Okay. So, example, a uniform ladder. This is example of ladder friction. Huh? A uniform ladder of length 3.25 meter. Length of ladder, that is 3.25 meter, and weight of ladder 250 Newton is placed again a smooth vertical wall. This ladder that is placed again a vertical wall with its lower end 1.25 meter from the wall. The coefficient of friction between the ladder and floor is 0.3. What is the frictional force acting on the ladder at the point of contact between ladder and floor, so that ladder will remain in equilibrium in this position? So in this example, there is a one vertical wall and there is a one floor, and there is a one ladder which is placed again this vertical wall. Okay. Now this is point A of ladder, this is point B of ladder, and weight of ladder that is in downward direction, and it is given 250 Newton. 250 Newton weight of ladder it is given, and length of ladder that is 3.25 meter. Length of ladder is also given, and distance of this point A from the vertical wall it is given 1.25 meter. It is also given in this example 1.25 meter, then length of ladder 3.25 meter, and weight of ladder 250 Newton. Now in this example at point A, this is point A. So here these two reactions. First one, F force of friction at point A, and second reaction in this direction, that is RF. So at point A there is a two reaction, FF and RF, and we know that weight of this ladder that is in vertical direction 250 Newton. Okay. Now in this example, given data, length of ladder 3.25 meter, weight of ladder that is 250 Newton, and distance between lower end of ladder and wall that is 1.25 meter. Now coefficient of friction between ladder and floor that is given mu F, it is equal to 0.3. Okay. Now frictional force acting on the ladder. Let FF, frictional force acting on the ladder at the point of contact between ladder and floor, which is point A. At point A, this FF it is equal to frictional force, and RF normal reaction at point A. Okay. Since ladder is a place again a smooth vertical wall, therefore there is a no friction at the point of contact between ladder and wall. Okay. Resolve the force vertically. Vertically there is a two force, RF which is vertically upward direction, and weight which is vertically downward direction. So RF is equal to 250 Newton. Now from the geometry of figure which is shown in first slide, we find that BC is equal to under root of 3.25 square minus 1.25 square. That is according to Pythagoras theorem. Okay. So it is equal to 3 meter. Now taking moment at point B and equating the same, so FF into 3 it is equal to RF into 1.25 minus 250 which is weight into 0.625. So it is equal to 250 into 1.25 minus 156.3. So it is equal to 156.2 Newton. So FF is equal to 156.2 divided by 3. It is equal to 52.1 Newton. FF, force of friction at point A. RF, reaction force at point A. And in this example, weight is given. Okay. Now, equilibrium of the ladder, we know that maximum force of friction available at the point of contact between ladder and floor. So, it is equal to mu into RF. Mu 0.3, mu means coefficient of friction. So, 0.3 into 250, that is equal to 75 Newton. So, we see that the amount of force of friction available at the point of contact, it is equal to 75 Newton, is more than force of friction required for the equilibrium. Therefore, the ladder will be in equilibrium position. So, this is example of ladder friction. One ladder placed against the vertical wall, and length of ladder is given and distance of vertical wall from one end of ladder on floor, that is also given. So we have to find out RF and we have to check condition of equilibrium of the ladder. So this is about today lecture. Thank you student for today lecture.